Hi all, welcome to section 2.2 through 2.4. I think we can finish them all in this lecture. So we're looking at basic properties of functions and their graphs, and then we'll look mostly at linear functions, slope and average rate of change. So let's jump right in. The first thing they talk about is intervals where a function is decreasing, increasing, or constant. And basically what you want to do here is specify the intervals for which exactly like they say, increasing, decreasing, or constant. But basically, what do those three things look like? Well, increasing means you're going up from left to right. And decreasing is going to mean the other way, so you're going to be going down from left to right. And then constant are just going to be the regions where your graph looks flat. And when they want you to specify these things, what they're really looking for is they're looking for you to specify the interval of x values. So basically the graph that they have shown here, it has two pieces, one where it's decreasing and one where it's increasing. And the x value where that changes is right here at -1. So if you kind of think about this, region over is the one that's decreasing, and then for increasing, I'm just going to draw it above so it doesn't get on top, but this region this way is increasing. So what we just need to do is specify those intervals. And then the point in the middle, you could say that it's constant, but there's not more than one point, so it's not going to be too big of a deal. It looks like this textbook specifies that they use open brackets to specify these regions, but there's no common consensus amongst math textbooks, so I'm pretty flexible if you use parentheses or brackets, but I think for the homework you're going to want to use parentheses. So the increasing is where we went from x equals 1 up to positive infinity, and then the decreasing is where we went from negative infinity all the way up to x equals 1. And then if you're going to say constant, the only place you could possibly say constant at is maybe just x equals 1. But that's it. Okay, so let's look at another thing, maxes and mins. So maxes and mins are actually pretty obvious notions. So we say something's a relative max or min if on a graph, continuous graph, it looks like it's the top of a hill or the bottom of a valley. So right here, these points are going to be what are called relative mins. If I kind of label them, say I call this point A, this point B, and this point C, relative mins are given by A and C, and your relative max was just given by point B. So you would say the relative minimums occur at the x value, and what the relative min or max would be corresponding to is the actual y value. How do we determine whether something's relative or absolute? Well, if it's the smallest possible thing anywhere on the graph, it's a global or absolute min. If it's the biggest thing anywhere on the graph, it's a global or absolute max. So notice A and C, points A and C, we would actually say are both relative and absolute mins because they are the smallest y values that occur anywhere on the graph. The graph never dips below 0, and at those points A and C, the y value is actually 0. B, however, is just a relative min, because if you see on the ends of the graphs, we actually have arrows moving upward. So eventually the graph is going to be much, much higher than point B. So although it's a min in this local neighborhood, although it's a max in the local neighborhood, it's not a max for the entire graph. So that would be a relative but not absolute max. And that's pretty much all we need to say about those. Don't need to go into too heavily details, but I mean, for the language you might see, let's just look at point B. We would say point, and instead of B, let's write the coordinates. 0, comma 4 is a relative max. That occurs at x equals 0 and has value y equals 4. So we would say the max occurs at 0 and the value is 4, because we're kind of determining whether things are big and small in terms of their y values, and we're just using the x values to locate where they're at. Okay, even and odd functions, basically they come from a certain kind of symmetry. So that's kind of the angle I'd like to take at them. So let's go back to this notes page and say a quick thing about even and odd functions. So even, odd. Basically, if your graph has y-axis symmetry, so if the graph looks the same on both sides of the y-axis, so hopefully I can draw a good graph here, something that looks the same on both sides of the y-axis, we would say it's an even function. So this has y-axis symmetry. An odd function is one where it has a different kind of symmetry, which is called origin symmetry. So let me give you an example of that. So this would be an odd function, and it's what's said to have origin symmetry. So y-axis symmetry is pretty basic. If you have a point at, say, value x, and you go over to value negative x, it is going to have the same exact height. Okay, so these points are on the same exact height. So if you think about the coordinates of the first point, it would have coordinates x, comma, and if we call our function f and the y value, you find the y value by plugging it into the function. Well, notice the height is exactly the same, so this negative x value would also have height f of x. So we get the algebraic condition, or the algebraic definition a function is even if f of x equals f of negative x. So we're actually able to check these things algebraically. And the origin symmetry, basically, if you take a point up here, so call this value x again, so it would have coordinates x, comma, f of x. And when you flip twice, so if you flip down here and then over here, that point would occur again. So again, this would be at negative x, so we flipped it down, and again this point has coordinates negative x, and then you can always get the y by just plugging it into the function. What's happening here though? Well, if you flip it exactly over, this would have height, this would be a distance negative f of x. So we get the algebraic definition now because this value has to equal this value. So the algebraic definition, I should probably be underlining these things, is we'd say a function is odd if f of negative x equals negative f of x. So if you're just given a formulaic definition of a function and they ask you whether it's even or odd, you need to check whether one of these two things holds. Algebraically, this notion comes from, like, let me give you a basic example of each, how we'd apply the algebraic definition. So, example, show f of x equals x squared is even, and then over here show f of x equals x to the third power is odd. So we actually get the names for these graphical notions based on the fact that any power function with an even exponent turns out to be even, and any power function with an odd exponent turns out to be odd. So how do we apply this? Well, you plug in negative x. So in the formula, this tells us that it's negative x squared. Can we do any simplifications here? Sure. That's negative 1 squared times x squared. Well, that turns out to be positive x squared. Well, what is another name for positive x squared? It's f of x. So through this chain of three equal signs, we've actually shown f of negative x equals f of x. Therefore, our function is even like we wanted. Okay, for the other one, odd, you still do the same thing. You still plug in negative x, but now we want to get something slightly different. We're hoping at the end of the day it looks like the opposite of the formula. So this will be negative x to the third power. And then when you simplify, so negative 1 to the third power is just negative 1, and x to the third power is x to the third. Well, this turns out to be exactly the opposite of the f of x formula, right? Because f of x equals x to the third, negative f of x equals negative x to the third. So we've shown through the three equal signs here that f of negative x equals negative f of x. So therefore that function is even with the definition we specified. Let's go back to the learning guide, look at ones that maybe are a little more interesting. 3a is going to be pretty much the same trick. We want to determine whether it's even, odd, or neither. We'll just plug in negative x and see what happens. So we get negative x to the third power minus x. So this is negative x cubed minus x. Well, to show what's the opposite of this f formula, well, let's factor out a negative. And what do we get? X to the third plus x, which leaves us with negative f of x. So we've shown f of negative x equals negative f of x. Therefore, the function is odd. G, we have an even power mixed with an odd power, so you can probably guess if we do g of negative x, we're not going to get anything good. So negative x squared minus x, we end up with positive x squared minus x. And so if it were the opposite, it would have to be minus x squared minus x, and if it were the same, it would have to be x squared plus x. So in this case, this one is neither even nor odd. And then if you look down at h of x, x squared minus x to the fourth, it's going to end up being even, and I will leave that for you to check. So check on your own. You just, again, plug in negative x, and if you do everything right, you will end up with exactly the same formula. Okay, so piecewise functions, a lot of people freak out when they see them, but they're really not too bad. The thing you need to notice is just basically, it's like a list of instructions. And here are the instructions. So the top part, this negative 2x if x less than or equal to 0, basically tells us if x is less than or equal to 0, double the input. And then if x is bigger than 0, we just return the value 2. That's it. So basically you can plug in any point you want into this function. Let's just look at a table of values, x, f of x, and see what we might get. So the interesting point happens at 0, so let's plug a few values in on either side of it. Negative 1, negative 2, and then we'll plug in 1 and 2. Okay, so negative 2, is that less than or equal to 0? It sure is, so we double the input. Negative 4. Negative 1, is that less than or equal to 0? Sure is, double the input. 0, is that less than or equal to 0? It is, double the input. Sorry, double the input would give me 0. Messed up there. Jumping the gun. Okay, so doubling 0 still leaves us with 0. Alright, now 1, that's bigger than 0, so we just return the value 2. 2, that's bigger than 0, so we just return the value 2. And pretty quickly you can see what's going on in the graph here. So at 0, we've got a line with slope 2, which we'll talk about in a minute. Right, so negative 1, 2, negative 2, negative 2, negative 4. This is basically the line that we have for the top piece. And then on the bottom piece, that's pretty easy. At 0, it doesn't happen, but for any number bigger than 0, we just return the value 2. So that's our function. That's why it's called a piecewise function. You've got two different sets of instructions based on what the x values are, and just think about what the instructions are and then apply them to each piece appropriately. Okay, difference quotient. This, I think, is out of place, so what we're going to do is we're going to talk about slope first, and then we will come back to the difference quotient. So that's it for this section, and it brings us to slope. And so after we learn slope, we'll come back to that. So let's get ready and talk about slope. Alright. Okay, so let's talk about slope. Probably most people have seen this before, but it's nothing too difficult. Whenever you have a line, what you'd like to do is measure the steepness of it. So basically slope measures steepness. And the way it does that, usually the letter we use to represent slope is just the letter m, and it's given by the change in y over change in x. So if we have 2 points on here, say this point and this point, and say the x values occur at x, and then I'm going to subscript it with 1, and the second one I'm going to subscript with 2, just to remind you that those are the x values. And we'll call the second point just y1 and y2. 1 for first point, 2 for second point. The way you'd calculate that is you'd look at the distance between the y values. So that would be y2 minus y1. And then if we looked at the distance between the x values, the way you would get those is you just do x2 minus x1. So the formula to get slope is just y2 minus y1 over x2 minus x1. Nothing too tricky there. Let me get the bottom x looking a little more like an x and less like a y. A lot of students wonder why it's why you're able to get away with using any 2 points and you always get the same thing. So this would be the notion of well-definedness. So let's just think about a picture real quick. So let's say I picked, so I had some line here. And let's say I picked these 2 points. So I'd basically be forming this triangle, and I'd be the vertical leg would be telling me the change in y, and the horizontal leg would be telling me the change in x. And then let's say I looked at this maybe smaller triangle over here, and I've got the same thing. Well, if you calculate the slope from the big triangle versus the slope in the small triangle, they should be the same thing. But why? Well, that's from geometry. Since these two triangles are constructed from the same line and are both right, they turn out to be similar. And proportions taken from similar triangles will be equal. So from high school geometry, you'll know that it doesn't matter what 2 points you take, you'll actually get the same value for the slope. So let's go back to the learning guide and actually calculate some of these things. So the first one says find the slope of the line passing through these 2 points. Now you can draw the picture if you want and form the triangle, but if you're good with the formula, then we can just jump right in. So remember, it's y2 minus y1 over x2 minus x1. So we have m, and it actually doesn't matter which point you call y2 or x2, y2, or x1, y1, as long as you're consistent with which value comes first on top and bottom. The biggest mistake people do is they like to put the x's on top because the x's come first. That's not how it goes. The change in y goes on top. So we're always looking at the second coordinates first. So I'm going to call this x2, y2 because it comes second. So I'll do 2 minus 1 on top And then on the bottom I'll do 2 minus negative 2 for the x values. So this gives me a slope of 1 over 4. And that's really it. Nothing too difficult there. Now we're going to talk about point-slope form and slope-intercept form. So these are going to be two things that are really important for your test. I'm going to be asking a lot of questions about finding equations of lines. Probably the biggest topic. So we already know that the slope formula already works. So basically the way to get point-slope form is just from the slope formula. So let's say that we're trying to figure out, let's say we have an unknown point, x, y, and then we actually know a point. Let's call it x0, y0. Now let's calculate the slope between these 2 points. Well, we do y minus y0 over x minus x0. Again, like I said, it doesn't matter that I'm choosing this one first, as long as y coming first on the bottom. On top means x comes first on the bottom. Now let's solve for y. So the way you'd solve for y is first you'd multiply both sides by x minus x0. So you have m times x minus x0, and when you multiply on the right by x minus x0, they just cancel. So we end up with this equation, m times x minus x0 equals y minus y0. And then you add y to both sides, and we get m times x minus x0 plus y0 equals y. And this is exactly what we call point-slope form. This form of the line is point-slope. So basically, if you know the slope m, and then you know a point x0, y0, you can exactly figure out the equation of the line. So let's go back to the learning guide and see if we can figure out how to get the equation of the line they're asking for. So they say write the point-slope form of a line with slope -3 that passes through -2, -3. So I'll first remind you of the form. So it basically looks like y equals m times x minus x0 plus y0. So for us, m is -3, x0 is -2, and y0 is -3. So we get y equals -3, and then we're going to do x minus -2, which means x plus 2, and then plus y0. We'd be adding -3, which is the same as subtracting 3. And this would be the point-slope form. For most of the equations, they're going to ask for it to be in slope-intercept form. So slope-intercept form basically means to solve for y. So the way we'd solve for y is we'd multiply out the parentheses and combine like terms. So we get y equals -3x plus 6 from distributing, and then we can put the 6 and the -3 together. So we get y equals -3x plus 3. And this would be called the slope-intercept form. So what does the slope-intercept form tell us? Well, exactly what the name tells us. So slope-intercept, you don't really have complicated parentheses. What you have is you have just y equals mx plus b, where m is the slope. And then notice if you plug in x equals 0, the mx goes away, so the point 0b turns out to be the y-intercept of your line. So if we looked back at the learning guide, -3 would be our slope of the line, same as we can tell from point-slope form, but we also see that the point 0, +3 is the y-intercept. Alright, we have a line passing through 2 points, and they want us to write it in slope-intercept form and then solve the equation for y, or write it in, first write it in point-slope form and then solve it for y, or write it in slope-intercept form. So when you have 2 points, the first thing we need to do is find the slope. So use the slope formula. And I'm going to do 4 minus -1, which gives me +1. And then I'm going to do 2 minus -3, which gives me +3. So I end up for this one with 5 over 5, which is just the value 1. Okay, so point slope form, again, that looks like y equals m times x minus x0 plus y0. So I'm going to use the point 2,4 just because I like the positive values, and I'm going to write it as y equals 1 times x minus 2 plus 4. So this would be point slope. Now we're going to do slope intercept. And the way you do that, notice 1, when you distribute it, doesn't do anything, so we can really just kind of get rid of it. You can think of it as distributing it as well, but it's the same difference. So we end up with just x minus 2 plus 4. We can put -2 and 4 together, and we get y equals x plus 2. And this would be the slope intercept. And that's it. You want to do a bunch of these, though, so like you don't even think about it, so they're just second nature, because I'll be asking you a ton of questions of this kind. Okay, let's move on. Graph a point. This is really easy, so we know this equation already looks like a line. You could plug in a bunch of points, or else I'll show you a trick. It's already in slope-intercept form, so let's just use that. So we know the slope equals 3 over 4, and the y-intercept is 0, -2. So let's make a graph. So we know this point lies on the graph. And then how can we use the slope to get another point? Well, remember that the slope is just change in y over change in x. So 3 over 4 means whenever we go up in 3 in the y direction, we have to go right 4 in the x direction. So just count up 1, up 2, up 3, and then to the right 1, 2, 3, 4. So that's the point that has to be on the line. So if we connect these two dots, that will be exactly the line that graphs the function. So just remember what I did. I found the y-intercept 0, -2, and then I counted. You can even do it the other way, right? 1, 2, 3, 4, because that's how it changes in the x direction. And then how does it change in the y direction? +3. 1, 2, 3. So it's kind of like we make a 4x3 rectangle and then connect the two corners. Okay, graph y equals -2. This we've actually covered before, so I'm not going to go into too much depth, but it just is the graph where every point is at height -2. One interesting point is this is a line. What is the slope? Well, the slope is 0 when it's flat. If you think about the change in y will always be 0 no matter what the change in x. If you draw a vertical line, I think that's the next one. Yeah, so they have x equals 5. This will be the line with all points having x coordinate 5. So if you come over here, 1, 2, 3, 4, 5, we're going to get this line. And then if you ask the question, what is the slope? Well, in the slope formula, y minus y, or y2 minus y1 over x2 minus x1. Here, the y values won't always, if you pick 2 points, the y values will give something different, but the x values will always give 0. So we say the slope is undefined, because you'd have a 0 on the bottom. And that's a pretty normal thing too, because a vertical line also will not be a function, because it does not pass a vertical line test. Okay, find the slope and y-intercept of a line with a given equation. Basically, your strategy here is to solve for y. So first move everything besides the 3y to the other side. So 3y stays on the left, and on the right 2x moves to the other side, so it turns into minus 2x. Minus 18 moves to the other side, so it turns into plus 18. Then we just divide by 3. And you have to remember, when you have one big fraction, you can split it up into two because that's a common denominator. So our function here will look like 2/3 x, negative 2/3 x plus 6. So if they ask for the slope and y-intercept, slope equals minus 2/3. Y-intercept is 0.6. Be careful on MyMathLab. They probably just want you to enter y equals 6 or 6. Yeah, see over here the way they write it, they say 2 is the y-intercept. I technically don't agree with that because the y-intercept should be a point, but so you'd want to write just y equals 6. Okay, this one they want you to graph. What do you think we're going to do? Again, just solve for y. And then we can graph it as before. So first I'm going to... For this one, I always want my y to be positive since I'm trying to solve for y. So I'm going to keep 6x and minus 12 on the left, and then I'm just going to move 2y to the right and divide by 2. So we get y, and then this will turn into 3x minus 6. Remember, common denominator, 6x over 2 minus 12 over 2 turns into 3x minus 6. So we know the slope is 3. And then the y-intercept, again, the way you would write this on Wiley would just be 6. Sorry, minus 6. So our graph we have the y-intercept, and then to get the slope, we just count change in y, 3, change in x, 1. So either up 3 this way and over 1, or you could start at the point and go up 3 over 1. Over 1, up 1, 2, 3. And then we have this dotted triangle, and you just connect the two corners. And that's our graph. Okay, number 7. What is the literacy rate for females in the country? When it's 0%, the mortality rate is 254,000. When the literary rate is 60%, the infant mortality rate is 110. So basically we want to write a linear function that models mortality for the children under 5 in the country where X% of adult women are illiterate. Use the function to predict when the child mortality rate is 80%. Okay, so the way to do this is just basically they tell you they want you to do a linear function, so that's the key, which tells us that we basically want to find an equation of a line. So what we need to do is find 2 points, and they tell us the percentages are the x values. So we know we have the point 0, and then the mortality rate is 254, and then we also have the other point, 60, and 110. So first thing, get the slope, and also notice quickly here that this is the y-intercept. So once we get the slope, we can jump straight to slope-intercept form because 254 will be the b value. So the slope, how do we get that? I'm going to do 254 minus 110 over 0 minus 160. Now we got to do a little work to simplify this fraction. So it looks like we have 144 over negative 160. Maybe we can simplify that. I know 12 goes into 144. How about, does 12 go into 160? No, it doesn't. Let's just do it piece by piece. So this is the same as negative 72 over 80. Okay, then I get it because I know that 8 can go into both. So I'm going to get negative 9 over 10. That'll be my slope. Okay, so now what's the equation of our line? Well, we have f of x, that's predicting the mortality rate per 1,000, is equal to negative 9 over 10 times x, which is the percentage, plus the y-intercept that we noticed at the beginning, 254. And they want us to make a prediction, that's the second part, like part B of the word problem, where 80% of the females are literate. So we'd be doing f of 80 is So we just need to plug 80 into for x. So let's come down here. So we end up with negative 9 times 8 plus 254. So we have negative 72 plus 254. See if I can add that. So 54 from 72 is 18. So I think we're taking 18 away. So I think that should be 188. And that would be the mortality rate. So how would we say this in terms of the word problem? When the literacy rate for females is 80%, the infant mortality rate is 188 per thousand. So when the literacy rate is 80%, the infant mortality rate is 188 per thousand. Alright. Oh, they got 62 per thousand, so I did something wrong in my math here. Let's see, does the answer make sense? 0, 254, 60, it's 110. So when it's 80, it should be lower. Okay. Let's see. It's okay to make mistakes. We just gotta figure out what happened. 254 over... Oh, I wrote 160 and it should have been 60. So I made a small little mistake. So let's go back through and correct that. I do apologize. We should have been getting 60 here. So that will change our fractions, which will change our answer. But the rest of it should be very similar. So 60 goes here. And then when you take it, so what did I do on the first step? I divided by 2 on top, so I divide by 2 on the bottom. And then what can I take out here now? I can again take away, well, I know I'm plugging in something divisible by 10 in the next step, so with that in mind, let's just divide by 3 and leave the fraction like that. I hope that's not too confusing, but this, if we take away 3 on top, divide by 3 on top, we'll get negative 24 over 10. So I know we can still simplify that further, but if we write the equation of our line the other way, it'll just turn out to be easier. Okay. So what should have happened? So our slope would be, well, I'll simplify it all the way. I don't know. It probably bothers you. So negative 12 over 5 would be the final simplification. Negative 12 over 5. So our equation would be negative 12 over 5x, and then plus 254, same as before. And then the next step, we want to figure out the mortality rate when the literacy rate is 80%. So we do negative 12 over 5 times 80 plus 254. So this will be negative 12, and then 5 goes into 80. 1, 3, 1, 6, 16. Negative 12 times 16 plus 254. And then what's negative 12 times 16? Let's see, that's 160 and 32, so I think this is negative 192 plus 254, which will give us 66, which is exactly what the answer was. Okay, so that was my mistake. We did everything correctly, but the problem was we put 160 on the bottom instead of just 60. So it's always good to double check when you're done, even if you're absolutely sure you got the steps right, because sometimes you just have a small mistake like that. So up here again on the bottom, I forgot to write 60. But yeah, so basically the parenthesis looked like a 1 to me, and I got a little confused. Alright, so I guess we'll stop here. I got 66 and they got 62. Okay, so I'm still off by a bit. I wonder if that's a... Alright, I'm going to pull out the calculator instead of doing all this mental math and make sure I didn't do anything wrong. Just to double check this one. I do apologize. So let's see. Let's just first check 144 over 60 and see if we get the same thing as when we do 12 over 5. Sure do. And then let's multiply that by 80. Make sure that's 192. It is 192, and then you add. So that was basically negative, so we did that minus 254 and then changed the sign. 62. Okay, so I just added them wrong. Okay, so we got it right. I just wrote the wrong number down. Alright, I do apologize for those silly mental math mistakes. I have not downed my first cup of coffee yet, and that could explain the silliness. Alright, so what I'm going to do is, this video is already 40 minutes long, so I'm going to end the video here, and then we will just come back to finish the very last section where we talk about average rate of change, which is actually nothing special at all, it's just slope. Alright, so I'll see you next video.